Algebra 1 linear equation, simultaneous linear function. Okay, this video shows how to solve the word problem. We pick typical word problem. Actually some of them are high school levels. Some of them they do it in the middle school. Depend on school. And it show you how to use simultaneous linear equation. Function become equation when you solve for the unknown value x, y, right? So the two linear equation become function. I mean the other way around. Two linear functions become equation. The equation is what you solve. Function is to show the relationship between variables. Okay. When somebody asks what is the xy value that satisfies two linear function, then those two linear function become equation. Okay, let's set the terminology right here. Now we have the algebra. There are a lot of word problem, but the two main subjects are often used. One is chasing problem. Okay, chasing problem is two different speed, like a car and a train, or Mike and a Kathy, or even the tank, the pouring water and draining water. Okay, the speed is different. So where they meet, okay, that's a chasing problem. Or the clock, long hand and short hand. These days you're not used to traditional clock. That's all digital clock, but traditional clock with long hand and short hand is often used in algebra as a chasing problem. The change with condition. Another type is you set a condition. For example, quantity 1 and quantity 2, you add them together, it should be certain number. With this condition, they talk about quantity 1 is such as such, quantity 2 is such as such. Then find out. Okay, so you can't have arbitrary number for quantity 1 and quantity 2 because they are bound by the condition. The example is condition 1 plus condition 2 is certain number. Okay, that's called change with conditions. So here's example. Mike left the point A by car toward B at the speed of 30 miles. Right? Cassie left the point A toward the point B 3 hours later. 3 hours later, but 60 miles per hour, which is a train, faster. So Kathy eventually catch up with Mike. So how long it's gonna take to catch up? This is chasing problem. Okay. Another example, the different example of the conditions is a party invites two kinds of donator. One donator $50 each and another $100 each. The number of invitee is limited to 50. Here's a condition. We don't know how many $50 donator and $100 donators, but both of them total should be 50. This is a condition. Okay. Then it's talk about total collected amount. Then figure out what's each donator's number, kind of thing. So you have a certain condition. The two values are bound by a condition. So this is a condition type of problem. So once you get used to those, when you look at word problem, you initially say, this is a type chasing or condition. You can easily solve it. Okay, I show you with several examples in this video. So you go through this video, the algebra word problem, particularly linear equation algebra, become very easy to solve. Okay, I hope you practice so that you are not afraid of word problem anymore. You will enjoy solving it. Okay, here's example 1, chasing problem 1. Kelly left the point A toward B 3 miles per hour. Okay, so let's break it down. A to B at 3 miles per hour, right? That's Kelly. And Jeff did the same thing at 15 miles per hour. Okay, because Jeff is on a bicycle. If the distance is 30 miles, distance is 30 miles. Where will they meet? Okay, so here we go. Jeff left 1 hour later. Jeff left 1 hour later. Okay, so let's visualize this in the graph. We take a time x and y. The reason is y is distance, and time is hour. The reason is we know it's very easy to say 3 miles per hour is y equals 3x, right? Y equals 3x. Okay, now Kerry start 1 hour later, 1 hour, right? But Kerry's equation is y equals, what is m? 15, right? But it's shifted to the x, so x minus 1. Okay, so we already got it. 3x, y equals 15, x minus 1. You just solve it. Then we know x and y, and this y is a distance, this x is a time. Okay, how you want to solve this? We plug in substitution method we talk about, right? Let's see, y, we replace 3x equals 15, x minus 1. Oh, 15 x minus 3x, because we move this guy here and we move 15 over here, so right, so it's a 12x 15, so x is 15 over Is that correct? No? Oh, do we need a total distance? 30 miles. Carry Jeff move from, oh, okay, so it's not Jelly left for point B, Jelly left B, so other way around. Okay, so if Jelly left from A to B, left for point B, then this is correct. Okay, now if Jelly left point B by bicycle for point A, okay, that's a different story. Jerry is 15 hours per hour. So 2 hours later, he is already finished 30 miles, right? So 2 hours plus he left 1 hour early, so 3 hours here. Jerry start from here and go opposite direction. Okay, so we're solving two problems now. It's ambiguity in the question. Jerry left at the same point A, then this is correct. If Jerry left B for A, then this is going to be the correct answer, because Jerry is, the graph is from here and it's going to be negative 15. Oh, this is correct. Instead of, well, I would say y equals negative 15 x minus 3. Okay, but same as this one. Okay, so according to this graph, Kerry should be this equation. I mean, Jeff should be this equation, and Kerry should be this equation. That's a Kerry, this is Jeff, and same here. So if you solve this, 2.5 hours later, and location is 7.5 miles away from point A. Okay, so in this problem we solved two problems. Because of the ambiguity of the question, if Jeff left point A toward B in the initial assumption, then this is the answer. If Jeff left point B toward A, then this is the answer. So answer sheet, assuming Jeff leaving point B toward A 1 hour later. Okay, so the either way you can solve this, right? I mean, this is very good practice. This we happen to have two similar questions with two different assumptions. Okay, I hope you like this. Next question. A car left point A at 40 miles per hour toward B. Okay, again, A to B, 45 miles per hour. The train left point A 2 hours later, toward B, or this time very clear, at 90 miles. Where can the train catch up with the car? Okay, so this problem happened to be same as the previous question. We assume Jeff left A toward B at the 50 miles 1 hour later. Exactly same question. Okay, it's became car and train. So here's the equation. 45 miles, this equation, and 90 miles, and 2 hours later, but it's faster, it's catch up here. Okay, you solve the question. So we solved this question in the previous example. So please look at the previous example. It's exactly same thing. Chasing problem 3. A clock shows 3 now. 3, I hope you know how the traditional clock look like. A shorthand is pointing 1, 2, 3, right? So this angle is 90 degrees. And when can long hand catch up? Okay, the speed of long hand per minute. Okay, 360 degree, 60 minutes. So it's a 6 degree per minute, right? Okay, how about shorthand speed? Speed of shorthand. It's move only this much, right? Which is 360 divided by 12 for every 60 minutes. So it's like 12 by 60, 360, 0.5 degree per minute. Okay, so you got the two speed. So you can make an equation. The shorthand start from here, longhand start from here. So handicap is 90 degree, right? So if you draw the graph, take a minute. This is minute. Y is degree, right? Okay. So what happened is shorthand start 90 degree from here. It had a handicap. Shorthand, longhand start from 0, catch up 90 degree and meet. So this equation, longhand is going to be y equals 6x, right? The shorthand is shorthand equals y equals 0.5x, and handicap y-intercept is 90. Okay, so we solve it. Just solve this xy, substitution method is fine. Then you get x and y. Easy, right? So what you do is you identify the speed of both hand and just make this graph the equation. Then you get it. Next question. The long hand of a clock is pointing 3. Okay. Shorthand is pointing a little after 6. So 3, 6. So time is 6:15. You can tell, right? I hope you can read the traditional clock. How many minutes later will be longhand meet the shorthand after 6:30? After 6:30, yeah, the longhand come. It's gonna be after 6:30. Round the nearest. Okay, so the same thing. Okay, longhand speed in the previous question we know 6 degree per minute. That's the speed. Shorthand speed is 0.5 degree per minute, right? And in the graph, you take x as a minute and the y is degree. Okay, so we don't know how much. The handicap is not exactly 90 degree, so that's a little complication here. Okay, but longhand stuff from 3 is keep going at the 6 degree per minute, right? So longhand is y equals 6x. This, let's calculate this handicap. The longhand moved 15 degree. The 15 degree divided by 6, right? That's how many minutes? 15, oh no, 15 minutes. 15 minutes times 0.5 is 12.5 degree shorthand moved during 15 minutes. So the handicap here is 90 degree plus 12.5 degree, right? Okay, so shorthand equation is y equals 0.5 x plus handicap intercept here 90 plus 12.5. Okay, so the answer will be some decimal number. It's messy, but you can just round off to the nearest minute and you can get the answer. Okay, so next problem is a condition problem. There will be a condition. Mike is younger than Cassie by 10. So Mike is 3 years later. The total age of Mike and Cassie will be 3 times larger than Mike. What is Mike's? Okay, so Mike's age is X. Cassie's age is Y, right? So initially, the Mike is younger than Cassie by 10 years. So this plus 10 is Y. Is that okay? And 3 years later, Mike and Cassie's will be 3 times larger than Mike. So Mike plus 3 plus Cassie plus 3 is going to be 3 times larger than Mike. Mike is currently X. Here you go. You just made 2 equations and solve this. Okay. Use a substitution method. Plug in Y here. Then X you can get. Right? Okay, let's keep going. We have too many example word questions, so we gotta keep moving. The density of silver is this, and gold density is this. A king gave 1 kilogram of gold to craftsman. Okay, the craftsman made a 1 kilogram of gold crown for king, but there were rumors that the craftsman mixed in some silver in the crown. The king ordered the mathematician to verify. Mathematician took a 1 kilogram gold bar and the crown and put them in water to measure the volume. Okay, the king's crown had 10% more volume than the 1 kilogram bar. How much silver did the craftsman mix into the crown? Okay, say silver is X, right? And gold is Y. Okay, so the volume, total volume, is when the silver is max. This is gram, right? And gold density is this. So you divide by density is the volume. This is gold volume, and you divide by silver density. So this is the total volume, which is 10% less than gold, the pure gold. So total weight is same. So X plus Y is original 1000 gram divided by and 10% more volume. So volume 10% more, 1.1. So this is the gold, pure gold volume times 1.1 becomes this, the mixed volume. Okay, and X plus Y total is 1000 gram. Is that right? Yeah, because weight is same. They measure the weight, the crown, and original 1 kilogram of gold, the weight is same. So this is the second equation. This is the first equation and second equation. So we know how to solve this. Next example is a little tricky. Okay, Jessica put the candies and chocolate in a bag to sell. The first bag had 10 more candy. Okay, so 10 more candies than chocolate and cost 240 cents. And Jessica reversed mixture by putting 10 more chocolate then candy in the second bag, and the cost was 380. What is the difference between the cost? Okay, it's not asking the cost of each, it's just asking the difference between the cost of chocolate and candy. Okay, so cost of chocolate is X, candy is Y, but we have to introduce one more, which is number of chocolate, Z. So the first bag has 10 more candy, so Z plus 10, total number of candy, right? So Z is a chocolate is X plus Z plus 10, Y equals 240 cents. The second, you reverse it, so Z plus ZY plus Z plus 10, Y equals 380. So what you do is you subtract this from this. So it's a 140 becomes, this goes away, and this let's see, oh, X, this one's X, right? So this goes away, so Z disappear, so it's become 10 X plus Y equals 140. So what happened is X plus Y, the total cost is 14 cents, right? And now it's asking the difference, so we have to go back. Its total is 14 cents. The 14 cents Z plus 10x, let's see, 10y equal 240. And let's see, okay, we made a mistake, we subtracted, so this should be negative, right? So the cost difference is 14 cents. Okay, so this is a little tricky one because easy to introduce third unknown value, but that's gonna disappear by symmetric equation. Okay, so okay, I hope you enjoyed this section of the Algebra 1. Thank you for listening.